So now we go to the writing experiments. So Mini-NDN provides a simple Python API. It's very simple API to use. And using that API, you can define topology and then a lot of your experiment behaviors. In addition to that, it also provides frameworks that allows external topology configurations that you can directly use in your experiment. So you don't have to always write topology from the script, but whatever topology configuration you have, which we obviously need to be in some format, you can take that and then use that in the experiment. This can be used to test codes with multiple topologies within the multiple topologies too, right? So that's what it offers. We have, and then we can use this API and frameworks to facilitate example that can be reproduced elsewhere. So, most of the time, what I personally have experience, like when I was doing something with testbed or when I'm doing something with Raspberry Pi, doing my stuff. Most of the time I'm kind of partially semi-partially able to replicate those results and experiments in the Mini-NDN. So it's very, very convenient in that way. So you can debug your actual network using Mini-NDN. And this also provides a robustness in the integration testing framework. So we already have an active integration testing framework, which for all of our changes in NLSR, we run those using Mini-NDN. The integration testing, we run them using Mini-NDN, so that we are mostly sure that it will not break any stuff when running the NLSR in testbed. So that's what we do. And even if we find some bugs in testbed, then we mostly use Mini-NDN and then do the debugging stuff. So it has been a very, very useful tool for us as well. Even for doing the integration testings and all the stuff. So now I will go with to the very basic example of how you can, how the example looks like. So we will take this simple topology where you would have two nodes, basically A and B, and then link delay is 10 milliseconds. The goal of this experiment to run Ndn instances on the node. This is how the topology configuration file looks like. You don't need to have a topology configuration file all the time. We have several mechanisms on how you can write topology file. I'll talk about that in a minute. But if you have, so you're basically saying you have a two node A and B, and you have a link which is A and B with a 10 milliseconds. So it's that's how we write a configuration file. And for that, what you need? So you need to import a bunch of stuff. Basically, import Nft and Nlsr application manager. If you need CLI, Mini-NDN CLI, you import all the stuff. And then second thing is you just clean up. So the thing that Alex was talking about, sudo -c kind of stuff. If there is anything existing in the system, if any stray instances were running from the previous experiment, this will just clean those stuff. And this one will verify the dependencies, if all the dependencies that we need are already installed on the system or not. If you're pretty confident about that, you don't need this line too. If you're pretty confident that your system doesn't have anything, you don't need this line too. But just for the practice, you need a NDN object, and then you start, and then you just need to start it. For now, the next step would be to run Nft and Nlsr. So we have an application manager which we use to run Nft and Nlsr. So here we start Nft, and this one here we start Nlsr. So basically, this will go ahead and run this instances of Nft and Nlsr on each node, that is A and B, and then this will pop up the CLI. So if you need CLI, then this is what you do. If you don't need CLI, then basically you just stop it. So let's say you're doing some experiments, you're automating some experiments, then you might not want to bring CLI. So in that case, you just stop the experiments and then see the results. So I'll be running this example later on. So bear with me on that. And yeah, this is how you run the experiment. So that's the final step and how you can run the experiments. And this is, this one is taking the argument, topology argument. So this is how you write a topology. You can save it anywhere you like, and then you give it as an argument. Also, this experiment script can be anywhere in the system, and then you can run it. So this is another example, a little bit more advanced than the previous one. So in this experiment, in this example, what I'm showing is running a ping server. So we have a bit advanced topology and also a different way of how you can write topology. So this one has this is a configuration of this topology. Here you can see that we are trying to, the server is running, we're trying to run a server in this prefix, last example. So the client will try to ping this prefix. So yeah, so the similar stuff. And so if you see, this is a new way of writing a topology. So in the previous example, I showed that you can have a topology configuration file, and then you can use that while running experiments. The another approach is also you can write the topology itself from this script. So Mini-NDN provides a topo object. You can use this object to create hosts and links. You can use this and then create host and the links. So if your network size is very small, then you don't want to bother writing a different configuration file for that. You can just use these and then write the topology inside the script. And then similar to the previous one, you start Nft and Nlsr. So one of the new things that you see here is a log label. So you can set a log label for the Nft and Nlsr. So this will set debug log for all the Nft instances and info log for all the Nlsr instances. So we need to sleep. This is a quite a lot sleep time. It's a 40 seconds, but this is a kind of this is because of the Nlsr, because it has to do a bunch of routing calculation. It is a little bit slow on that side, and then install the routes. So it will take some time, for Nlsr to converge. So this is basically a convergence time for Nlsr. And then you need this node is made as a server. You see this node C, we made this node server, and then you have to advertise this prefix, which is /example, so that all this node can reach to that prefix once it is advertised. So NLSRC is a command. This is a utility provided by Nlsr to do a prefix advertisement, so that all the node in the network can reach to this prefix. So this is a utility Nlsr. So if you have most of the examples when we write, we have different consumers, different producers, and all this stuff, and then we use a very different prefixes for those cases. So this is how you can advertise your prefix from the node. So this one is showing that how you can run a Ndn Ping. So we use a utility Ndn Ping server. So this is under Ndn tools. This is one of the Ndn packages. So it's also one of the dependency of Mini-NDN. So you can use with Ndn tool, you can use Ping server, and there are other different tools that is provided by this package Ndn tool. This is running the Ping server on the node C. And here you see we're running Ndn Ping, another command to ping this node, that is, to ping this prefix, /example prefix, and some argument like ping it for 5 times. And you wait for some time, basically, for that to complete, and then you print it out. That's what we're doing here. And then you bring the CLI. So this is a little bit advanced form. So one of the things that you can see from here is, just like Ndn Ping server, you can run any other command line from here. Let's say you have written a consumer example of your own or a producer example of your own. You can just run that from here. Or you want to log, if you want to capture all the packets, then you can run tsark or whatever in a node. So that's why it's pretty easy to run external or third-party applications from Mini-NDN. We will see how this experiment works. I mean, I will also probably show you this experiment later on. So there are a couple of things that I find myself, that other people should know before they start writing more complex experiments or more experiments. These will be very handy when you actually play and then use Mini-NDN for your experiments. So one thing is creating topology. I've already demonstrated, we already seen a few of the mechanisms on how you can create topology in the previous slides, but I'm going to go through it again so that at least something will remain in our mind, so that we can later on try this. We have multiple ways, as this explains. So one of the thing is through experiment script, which I've kind of shown you previously. So inside your experiment script, you have a topo object, which is provided on Mini-NET. You can use this topo object to create hosts and then add links. So if you want to create this simple topology of 2 nodes, then you can just do this inside the scripts and you're done. Yeah, as it's easy to write, but the concept is that it might not be convenient when creating a large topology. You might don't want to write A, B, C, and all those node names. So in that case, you might want to use some standard configuration files. Easier way it will be easier that way. So we also have a Topology Creator of Gui, which I don't have any the demonstration for that today because I got some problem with the VirtualBox setting the GUI on a VirtualBox. But we have this Topology Creator. If you want to know more about this one, just let me know, and then I can tell more. Or you can send an email to our mailing list as well later on. I'll give the details about the mailing list. The third way is to manually, you can write a configuration file, as we've been saying. So if you want to write a wire topology, this is how it is structured. You have nodes and links, and then you can have a bunch of other key values pair in here. So you can specify those as well. You can also specify what kind of log label you want to set for this node. Like for instance, if you want to set log level debug for a node A, and then let's say if you want to set log level debug for an NFT on node A, then you can specify that here as a key value pair, and so on for the B. So you can specify those stuff. You can also specify other key value pairs here. This is for the wireless topology. You can see how it is structured. So we have station access point links. We also have cars. We don't have any details about the cars in here. But you can have a bunch of station runs and speed of this station. In some cases, if the node is moving, then this you can specify those stuff. How you want that to be configured, and you can also specify access point, the positions and the range, and the links. So this is how you can configure the wireless topology too. We have a lot of examples of topology configuration in this link here. Maybe I'll just go with that. We can see. So yeah, so we have a testbed topology, the current NDN testbed topology. So the current NDN testbed uses a hyperbolic routing, so that's why it has a radius and an angle. I mean, you guys might not be familiar with what hyperbolic routing is. If you are, then you already know. But if you're not, then this is kind of trying to show that you can use this. This is how you can use additional key value pairs. We have a bunch of wireless topology options too. You can browse around this, and then you'll have a better idea of how you can write your own topology. Another thing is setting log labels. So this is also an important thing, because most of the time what I do is personally I set like a different log labels to collect the logs, and then collect my matrices or what I'm interested in, like computing the delays or computing other stuff. So that's why I wanted to emphasize that how you do that, how you set those things in the script. So yeah, it helps to debug and collect results, and then it can be used later to produce a different results for your experiments. Can set different log levels like info, debug, and trace on these nodes, like for NLSR and NFT. This can be done via configuration script. As I was talking previously, you can do this, set a log level for NFT at node A, debug log level. And for NLSR, you put debug, and for node B, simply putting info. So based on which node, let's say if you're interested, your application is running a node A, and then you want to see that if your application is sending the packets or communicating properly, then you might want to set this debug or interest log level to track, those stuff. And if your application, if all the nodes are just, if they are used for just a router and not doing any of those applications or not running anything, then you might not be interested in running a debug log level. So this is how you can configure from the script. We can also do that from the experiment itself, like from the experiment script itself. You can set like this, which we already saw in the previous slide. Another thing to know is like creating phased routes and setting strategy and many more. So how can you do that? So we can use Nftc utility for this, because Nftc provides command line utility to create routes, create fares, adding routes, and then setting strategy, and then doing a bunch of all this stuff like clearing cache and all this stuff. So we can run each of those commands using this utility. We provide wrapper also for this utility. For example, we have this Nftc wrapper around the Nftc utility. This is an example of setting a strategy for this prefix. If you want to set, so this also comes very handy when you're doing experiments. You want to set a strategy, let's say for sync, like if this is your sync prefix, if you're doing something related with sync, then you might want to set a multicast strategy for that prefix. Then you can use this tool to set up different strategy. So what I was trying to show was like our Nftc already provides this different other strategy that you can set, like a multicast strategy or other bunch of other strategies like best route or other strategies that you can already set that using that Nftc wrapper. I just wanted to show you that how it is done. Yeah, this is our Nftc wrapper script. So these are the strategies that you can set. A bunch of them are here. Also, you can specify when you are, creating routes and faces. You need a bunch of other options. So you can also use those. Another thing is you can directly, if you don't want to use a wrapper, then that's also fine. You can directly run this as a command in a host. Like you have a host, then you want to set a strategy for a particular prefix, then that's what you can do. Like you can just directly run an Nftc command. Mini-NDN already provides this feature. You can run a command in each host. So yeah, this is also how you can run. The prefix advertisement is also some thing that we usually get questions about, how you can advertise your own prefix. So for that we use an NLSR C command. So basically use the same structure here. You have a host and then you have a command. You run a command, NLSR C command, advertise prefix. That command, NLSR C command, can be run to advertise your prefix from the host. So that's how you can advertise your prefix. Yeah, another thing is a routing helper. So sometimes what happens is, most of our experiments, like by default, we use NLSR for route management, computation installation. So, but in many scenarios, people might not want to run whole routing protocol because that might incur a lot of overhead in terms of memory and CPU. And that's why we came up with this routing helper. So we recently developed this module like maybe 1.5 years, 2 years ago. What it does is it computes either link state or hyperbolic routes and then install them into the feed. So you don't have to run the whole NLSR. It's like a more static routing stuff. You will not obviously get the benefits of routing. Like if something fails or all those things happens, then you would have to. You can have that, but what we think is in the emulation experiments, you control your environment. So if you don't need a routing protocol, then you can ignore that, because mostly you control the environment and then the random behaviors might not be there. So most of the time it should work. This is still a work in progress. We want to we are working to support node and link failure on this routing helper. So you want if you want experiments where you want to fail some link or nodes, then also use then it will be helpful if we will have that feature in the routing helper. So we are working on this. Hopefully it will be soon. As Alex said, the manpower is the main issue, but if you want to contribute also, we're also feel free to contact us. But yeah, this is something we're working on right now. We also provide an IP routing helper. So what it does is basically configures this static IP route to all the nodes. So if you are doing some experiments that simultaneously requires IP stuff and then NDN stuff, some comparison stuff, then you can use this module to compute the IP routing. Yeah, this is another thing that I wanted to emphasize is that we support Mini-NDN. We have a support for Wi-Fi. So our module is Mini-NDN Wi-Fi. This is now integrated inside the Mini-NDN itself. So fully integrated inside the Mini-NDN. So this is basically an extension of Mini-NDN based on the Mini-Net Wi-Fi project. So Mini-Net is one project. Previously, we had Mini-NDN based on Mini-Net, and then we started working on Mini-NDN Wi-Fi based on Mini-Net Wi-Fi. So Mini-NDN Wi-Fi is based on Mini-Net Wi-Fi. This project Mini-Net Wi-Fi is also actively maintained, so we are in line with the project. So we have tried and tested a couple of scenarios, and it seems like it's working fine. I have tried it myself, so yeah. So and also we are doing more enhancement to the Mini-Net Wi-Fi so that we can support more features. This one, it incorporates the the emulates the wireless networking and mobility simulation. So this is something that a lot of people are interested in. It uses several mobility model like a random walk, Gauss Markov, and random directions. So these are the mobility model. Some of the mobility model. There are also other mobility models that are supported. They are basically from Mini-Net Wi-Fi. So that's why Mini-NDN Wi-Fi also supports them. To simulate a medium, it uses this kernel module. Like for instance, you want to simulate some loss for ingress and traffic, then it uses this module to simulate the medium. So it has the ability to configure loss, jitter, and bandwidth. We already saw some of those on the topology file that I showed earlier. It also supports ad hoc networks and mixed topology. So mixed topology is also an interesting thing. If your network is a little bit kind of a complex, where you have wireless and wired node both, then you can also have that with Mini-NDN Wi-Fi. As I said, it's fully integrated to Mini-NDN. Yeah, so this is also interesting. It's up for people to check out. So this is a topology configuration for Mini-Net Wi-Fi. Already shown this example before, but yeah, it has a station. You can have access point links, and then you can have a bunch of configurations for in stations and links and all the stuff. You can see more detailed about what are the properties the station have and access point and links have on the documents, Mini-Net Wi-Fi documentation, which I've shown in the previous slide. This is one of the simple Mini-Net Wi-Fi example. It's pretty much similar to how Mini-NDN Wi-Fi, Mini-NDN is, the example in Mini-NDN. So this is a simple ping example where you have 2 stations and 1 access point. The topology is configured inside from the script. Uses is create a face and then register a route, and then you run the ping between from a node A, to this prefix. Yeah, this is a very simple scenario, and then you just run a Mini-NDN Wi-Fi CLI. So we have a Mini-NDN Wi-Fi CLI as well. So you can use this CLI to do a lot of navigation stuff. Probably I will be running this experiments as well later on to see how, in an actual demonstration.